Hi, this is Mark Roth, and this is Mathematics for Social Justice. So this is part 2 of the consecutive number puzzle. Now, in part 1, we were talking about adding consecutive positive integers. For example, like 1 plus 2 plus 3 equals 6. And for example, 7 plus 8 is 15. But we weren't able to do powers of 2. And I provided a proof that I learned from John J. Watkins. But today I want to do my own proof. So the question is, how come you can't add consecutive positive integers and get a power of 2? And the powers of 2, again, are 1, 2, 4, 8, 16, etc. Well, let's break it into two cases, an even case and an odd case. First, we'll start with the even case. So that means we'll be adding an even number of summons. So suppose we're adding 7 plus 8 plus 9 plus 10. How do we know that can't be a power of 2? Well, the reason is when we add these two numbers, we get 17. And we add these two numbers, we get 17. And it's going to be 17 times 2. Notice we have an odd factor. Well, we're always going to have an odd factor because when you add a number to its successor, one of them will be even and one of them will be odd. So if that's even, the next one will be odd. If that's odd, the next one will be even. So we're always going to have this middle core here to be an odd number and then the same odd number. So in other words, we're going to have an even factor or an odd factor times an odd factor. One of these will always be an odd factor. And when you factorize a power of 2, you never get an odd factor. That basically concludes the argument. When you're adding an even number, like you can go further. If you added a 6 here and an 11 here, you would just get one more 17. That would be 3 times 17. But you're always going to have this odd factor. This 8 plus 9 is going to be odd, no matter what these two consecutive digits are. And then you just get another of the same sum, and then another of the same sum. But you're always going to have a certain number of that original odd answer to your first addition. Now, the second case is what is if you have an odd number of factors. So in case 2, suppose we have an odd number of summons. Suppose we have 2 plus 3 plus 4 plus 5 plus 6. Okay, if we subtracted 1 from the 5 and put it on the 3, subtracted 2 from the 6 and added it to the 2. So here we're moving 1 and here we're moving 2. We end up with 4 5 times. Okay, so the point is we have a number that's even, but we have 5 of them because we have an odd number of summons. So it's going to be 5 times 4. So when you have an odd number of summons, it's going to be equal to that odd number times the average of all these numbers. So the point is you're always going to have an odd factor. And when you have an odd factor, it can't be a power of 2 because powers of 2 never have an odd factor.